Hello, students. You're welcome onto the platform of Altedemy. I'm Vishwajeet, welcoming you onto this live streaming of mole concept. But before I move ahead, I would like to know a couple of things. How is the quality of broadcast? How do you find that the quality of broadcast is coming up to you on the scale of 1 to 10? Are you finding it okay? You can continue with us. Okay. And the second, as usual, we ask, how is your state of preparation for the examination? Obviously, we want to help you in making your preparation. But still, on the scale of 1 to 3, you can choose to press a button of your choice. We will expect you to press button 3, that is green, that your preparation is very good. Right. Okay. This is Vishwajeet Poddar. I am chemistry NEET faculty at Altedemy, and I have taught in many organizations, and in fact helping a lot of students to clear their JE and NEET examination. And I'm before you with the same purpose, and I hope you will enjoy this journey. Today the topic that we have chosen, and the topic is mastering mole concept. So this is a topic which is very basic in nature. Still, you need to understand the intricacies of mole concept very clearly. With my experience of teaching students, I have often noticed that when we start asking questions which are slightly typical, slightly difficult, which are based on a stoichiometric calculations, which are based on redox reaction or something related to mole concept solutions like some such chapters, we have noted that the students are often stumbling. They're not having their fundamentals regarding mole concept very clear. That's why I decided to choose a very fundamental topic and wanted to make all the concepts very clear to you. So, well, are you ready? Are you ready to travel to the journey of mole concept and ready with Altedemy? Fine. If you're ready, good evening. Good evening, Izimu. You're welcome. You're welcome. So, you're ready. You're ready to travel the journey of mole concept. I'll try to teach it slowly, slightly slowly, just because it's a concept that you have to imbibe, you have to understand, you have to start feeling what mole concept is. Then only you will start solving the problems of mole concepts very easily, right? Okay, we are moving ahead. You can choose to put your remarks or put your questions in your message box. I'm constantly watching it, and I'll definitely try to answer your question to this video lecture. Okay, look, we have a caption out here. I have tried to collect a couple of pictures, and these are not only pictures. On left hand side, we have put some elements, commonplace elements. We have carbon, we have iron, we have magnesium, we have calcium. These are the elements, commonplace elements, you know that. And on the right hand side, we have some compounds: water, calcium carbonate, sodium chloride, sulfuric acid. Well, can I expect that you know the difference between an element and a compound? Yes, I can. I think you know it. I do not want to underestimate that. Elements make compound when there is a combination of elements that make a compound. And when you start breaking elements, the smallest piece of element that you get, if I write it this way, no, I will not write it. I'll write it in the next slide. The smallest part of element, we call this as an atom. And the smallest part of a compound, we call this a molecule, right? And elements make compound. Therefore, we can say that atoms make molecule. Hi, Bharat. Hi, Hania. Sharon, welcome. Okay. So once we are familiar with these elements as well as compound, now your teacher asks, here is your teacher. Have you touched them and have felt the weight? Have you touched them and have felt the weight for calcium, for calcium? Yeah, Hania. Okay. We will definitely send this link to you later, Hania. But I'll expect you to continue with us right now. You can talk to me. Fine. So have you touched them and have felt the weight? Well, obviously, if you have taken up calcium or you have taken iron in your hand, you must have felt that it contains some kind of weight. So you must have. And you also know that these substances, we have talked that elements, the smallest part is an atom, compound, the smallest part will be molecule. Obviously, they are made up of some particles, right? So we can generally say that suppose we have this matter here. This matter is an element. On one hand, it will be having some particles, and on the other hand, we are noticing it is having some kind of weight. So, don't you think that there should be a connection between weight and number of particles? Very easy, very logical to understand. That obviously, if a substance has got some particles into it, there is some weight. So, particles and weight are somewhere related to it. Did you get it? Now you have started the process of starting mole concept. Welcome to the world of mole concept, right? Particles and its weight. Okay. Coming to other aspect. Well, we take element, along with element we can take even compounds. And among compounds, we have substances like they are in the solid state, they are in the liquid state, they are even in the gaseous state. Even with compound, we notice that compounds, some of the compounds, you will notice that they are in the solid state. Some compounds are in the liquid state. Some compounds are in the gaseous state. And I hope you can name many of them which are in solid state, some of them who are in liquid state, some of them are in gaseous state, right? Same with elements. Some of the elements are in solid state. Some of the elements are in liquid state. Mercury is an element which is in liquid state. We have some elements also which are in gaseous state. Can you name some of them? Can you name some of the elements which are in gaseous state? Anybody to respond? We have some elements like noble gases. Noble gases are found in elemental form. Yesterday I helped you in remembering periodic table: helium, neon, argon, krypton, xenon, radon. These are noble gases and they are in elemental form. So now we are adding the third dimension. Now we have particle, we have weight, and we have third thing, that is the volume. And we are compelled to think over this fact that are they related? And that is all where we are talking about mole concept. Mole is just a term which associate all these three aspects, that is of particle, weight, as well as of volume of a substance. Right? Okay. We'll take up one by one. One by one. So we can conclude that volume, weight, and number of particles are related to each other. And there we have the concept of mole that has come in between. Right? Okay. It is connecting. You can understand like this. If you write mole here, you have mole can be expressed in terms of volume of a substance, be it element, be it compound. We are talking about element and compound only. They are only pure substances. Pure substances are element and compound. Right? So we are talking about element and compound only. We are talking about pure substances. We are not talking about mixtures right now, because matter can be classified as pure substances and mixture. Mixtures are homogeneous and heterogeneous mixture, and pure substances are element and compound. This classification, I hope you must have read it. Anyway, mole is just an entity which is connecting volume on one hand, particle on the other, and weight on the other. Weight on the other. Particle, volume, as well as weight. These three things are being connected through mole. You should understand it at the outset. For any element or any compound that we are talking, you can relate its volume, its number of particles, and its number of weight, and its weight. Fine? This is the first thing that mole gives. Okay. Look, 1 mole of an element. Suppose we are saying, we are taking up an element and we are saying 1 mole of an element. The first thing that we say, 1 mole of an element has got 6.022 into 10 to the power 23. At some places we write 6.023. Let us not get fussy over that. 6.022 or 6.023, it is one and the same for us right now. Doesn't make much of a difference. Into 10 to the power 23. We write it like this: 6.022 into 10 to the power 23. I will write it 6.023, and this we call as Avogadro number. This we call this as Avogadro number. Okay. You must be familiar with this number, Avogadro number. Are you? 6.023 into 10 to the power 23. Yes, you are. If I tell you that, is it countable? How somebody has counted that it is 6.023 into 10 to the power 23? How this figure has been reached? This is an answer you have to discover. Of course, I can answer it, and if the time permits, I will definitely let you know how this particular figure 6.023 into 10 to the power 23 has been found out. Join me in chat. I'll definitely give you the answer, give you the discussions over it. How have we reached to this particular figure? Right now, I am not going into it. How did we discover? The thing is that we discovered it. It is 6.023 into 10 to the power 23. It's very huge a number. Imagine a number. It is more than that. Million, billion, trillion, quadrillion, quintillion, heptillion, nonillion, decillion. It is much more than that. So you can just understand how big this particular value is. And the first thing that you should remember, 1 mole, if we are saying that element, 1 mole of any element, I should write any element in the side base of it. 1 mole element is equal to 6.023 into 10 to the power 23 atoms. You should not have any two thought about it. 1 mole is equal to 6.023 into 10 to the power 23 atoms if we are talking about an element. And if we are talking about 1 mole of a compound, 1 mole of a compound, this again is 6.023 into 10 to the power 23, but this is molecule, right? So whether it is element or it is a compound, 1 mole stands for 6.023 into 10 to the power 23. It may be atoms, it may be molecules. Okay, it is altogether a different thing that later on we will be calculating 1 molecule is equal to how many atoms. Suppose it is asked to you and you have to give me answer in your chat box. Suppose I ask a question: 1 molecule of H2SO4 contains how many atoms? Can anybody answer me? Answer me carefully. 1 molecule of H2SO4 contains X number of atoms. Anybody to answer? Anybody to respond? Do it quickly. Do it quickly. Okay. Coming to the part of it. We are continuing with that mastering mole concept. 1 mole of an element. It is one thing that we have to understand. 1 mole of a compound, it again has got a different connotation, different meaning. None of you replied that one molecule of H2SO4 contains how many atoms? Both have different yet similar parameters. And let me elaborate it. Right? Okay. Suppose we are taking an element, and that is iron. Very commonplace atom. You know that. Iron is an element. And when it is an element, obviously it will be composed of atoms only. So if we are taking 56 gram of iron, and 56 we understand is the atomic weight of iron. Atomic weight of iron. And we have expressed this atomic weight in gram. So the first thing that we are writing, that 1 mole of iron, this is 1 mole of iron is equal to 56 gram of iron. The first thing that we have connected weight with mole. We have connected weight with mole. I hope you are getting it. And the second thing is 1 mole of iron, as we said, contains 6.023 into 10 to the power 23 atoms. Now here you can say 6.023 into 10 to the power 23 atoms of iron weigh how much? It is 56 grams. We have connected atoms and weight. Look here. Gradually we will be increasing the intensity. I am moving it very slowly, stepwise, connecting one thing, then two thing, then three thing, then four thing that we will be connecting. Welcome, Athar. Welcome, Athar. You are not late. We have connected atoms of iron with its weight. So anything that is said to you, either it will be said about an element or it will be said about a compound, right? If an element is being said or element is being discussed, then you should understand that first, without saying anything, you take its atomic weight. That is the first thing. And then take 6.023 into 10 to the power 23. Attach them. So you can say 56 gram of iron is equal to 6.023 into 10 to the power 23 atom. That's all. The first step that you have covered. And from here, multiple types of questions can be found. Multiple types of question can be found. I am taking another example to elaborate the matter. I am taking neon. Now, as I told you, neon is one such element which is in the gaseous state. Among elements, noble gases or inert gases are those substances which are generally found in gaseous state. So I have taken up neon. And the atomic weight of neon is 20. Now, what are the repercussions if we take it on the parameter of 1 mole? If we write 1 mole neon, what does it mean? First thing, it will mean that atomic weight of neon. And what is that? So we will write 20 gram neon, right? And the second thing that we can relate is 6.023 into 10 to the power 23 atoms of neon. This is the second thing. And these two are connected. And I am now adding a third parameter. Just because neon is found in gaseous state, so for gaseous substances, it is more important to talk about its volume. And for neon, if we take 22.4 liters of neon at STP, this you will have to remember. Again, it is an experimentally determined fact, so I cannot choose to alter it. 22.4 liters of any gas at STP, and all these three things are connected interchangeably. Getting the point? In case of neon, which is a gaseous substance, you can say 6.023 into 10 to the power 23 atoms of neon is equal to 20 gram, and that is equal to 22.4 liters of neon at STP. I would like to tell some small thing about STP also. There are two terms that we are using frequently, STP and NTP. For your purpose, you will treat both of them synonymously. STP is equal to NTP unless and until somebody mentions do this or do this changes or do that changes. Don't change it. STP and NTP should be treated one and the same, and it is called as standard temperature and pressure. That is one thing. And this is called as normal temperature and pressure. And they are almost similar. You will not do any kind of experiment. And what is temperature in standard temperature and pressure or normal temperature or pressure? It is 0 degrees centigrade or 273 Kelvin, or both, you will say. And pressure, you will treat this as 1 atmospheric pressure. Not to forget that STP means whenever you are talking about any gas, you need to specify this thing very clearly at what temperature and at what pressure we are talking about the volume of a gas. Without talking about a particular temperature or a pressure, talking about the volume of a gaseous substance is not something which is acceptable, right? 22.4 liters at what temperature and pressure has to be mentioned. So STP is that. Okay, can we move ahead? I hope you are enjoying, right? Yes, you should enjoy. Okay, now besides an element, now I am taking up a case of a compound. Well, whenever you are given a question, be very careful about it. Whether you are asking about some element or you are asking about a compound, this is something which makes a lot of difference, as I told you, right? Okay, now if we take a compound, let us say NaCl, calculate molecular weight of NaCl. There, in the case of elements, we had calculated atomic weight. In the case of a compound, as we are taking with NaCl, we will be taking up its molecular weight or molecular mass. In chemistry, generally weight and mass we treat synonymously. Okay, synonymously. In fact, we do not give much importance to acceleration due to gravity, right? But as a student of physics, you know there is a difference between mass and weight, but we do not differentiate for our purpose and for our calculation. So you can say molecular mass also and molecular weight also. Not there is no difference absolutely from the point of view of chemistry, and from the point of view of physics also. So NaCl, its molecular weight has been calculated to be 58.5. Well, here I would like to ask, are you aware of atomic weight of different elements and how do we calculate molecular mass of a substance? Do you know that very clearly? Let us suppose if I tell you to calculate molecular mass of glucose C6H12O6. How many of you can find it out? Give me the molecular mass of glucose. Do it fast. By the time I am explaining certain thing, I should expect some answer. Molecular mass of glucose. Then we will understand, you know, how to calculate molecular mass. Well, here I have calculated the molecular mass of sodium chloride is 58.5. For sodium, it is 23. For chlorine, it is 35.5. We added them to get 58.5. Now, the first thing that we can say, 58.45 gram of NaCl is equal to 1 mole. 1 mole is equal to 58.5 gram. That is the first thing. And the second thing is 1 mole of NaCl is equal to 6.023 into 10 to the power 23 molecules of NaCl. 6.023 into 10 to the power 23 molecules of NaCl. Okay. Got the point? You're getting something? Should I ask you a small tricky question here? Okay, try solving it. How many atoms, how many atoms are there in 1 mole of calcium carbonate? How many atoms are there in 1 mole of calcium carbonate? How many total atoms are there in 1 mole of calcium carbonate? Look, for solving this, first see calcium carbonate. Just by looking at calcium carbonate, you can say that if I pick up 1 molecule of CaCO3, we will get 3 plus 1 plus 1, 5 atoms in toto. Got the point? 1 molecule of calcium carbonate contains 5 atoms in toto. 5 atoms total. And if I am taking 1 mole of calcium carbonate, obviously there will be how many? 6.023 into 10 to the power 23 molecules of calcium carbonate. So number of atoms, as you can see, number of atoms is equal to 5 into 6.023 into 10 to the power 23. Tell me quickly whether you understood or not. Very quickly. Sharon, Hanya, Bharat, Atharv, please respond. Did you understand or you got me or not? How for a compound atoms can be associated with a mole? Okay? Okay. There is yet another concept. We call this as AMU. That is atomic mass unit. It is also written as U, which is also known as unified number. Unified number. Right? Which part of it that you wanted to explain? You wanted me to explain? Lemma? Okay. You got confused. Okay, I'll explain it further. Look here. Suppose I took 1 mole of calcium carbonate. Right? Now, as I told you, 1 mole calcium carbonate. Now, if I am taking 1 mole of calcium carbonate, there are 3 things which are connected. First is what? First is the weight. So first we calculated the molecular weight of calcium carbonate. And the molecular weight of calcium carbonate comes to be 100 gram. So first thing, this is connected. CaCO3, calcium is 40, carbon is 12, and oxygen is 48. So that makes it 100. So 100 gram calcium carbonate is equal to 1 mole. This is the first thing. Now, second thing, it is having 6.023 into 10 to the power 23 molecules. It is having 6.023 into 10 to the power 23 molecules. Now the question is something twisted. I asked how many number of atoms in 1 mole of calcium carbonate. First we calculated number of molecules from here to here. So we got how many molecules? 6.023 into 10 to the power 23 molecules. I hope you do not have a confusion out here, Sharon. You do not have a confusion. 1 mole of calcium carbonate is equal to 6.023 into 10 to the power 23 molecule. Now pick up 1 molecule of calcium carbonate. And you know what? Molecules are made up of what? Molecules are made up of atom. If I ask you 1 molecule of calcium carbonate is made up of how many atoms? You can clearly see to it. There is one atom of calcium here, one atom of carbon here, and three atoms of oxygen here. So total 3 plus 1 plus 1. There are 5 atoms in one molecule of calcium carbonate. Right? So one molecule has this many molecules. If you are calculating number of atoms, one molecule has 5. So 6.023 into 10 to the power 23 molecules will be having this multiplied by 5 number of atoms. I hope it must be clear to you. Thank you, Sharon. Thank you, Lima. Moving ahead. This is concept of Avogadro number as counting unit. Look, you try to follow what I am suggesting you. In a question, you can be given three things. Either you can be given number of particles, you can be given number of particles, that is first thing, or you can be given weight of a particle, you can be given a weight of a particle, or you can be given volume of a substance or an element or something like that. In any question, if a question will be given, you will find either you have been given some number of particles or some weight of certain things or volume of something. Now, you remember the three formula. First, mole is equal to, mole of any substance is equal to weight given, whatever weight given in gram, divided by atomic weight or molecular weight that you find out. Atomic weight or molecular. That is the first formula. Second formula for finding out mole is equal to particles given. You need to be very clear what is given to you in the question. Whether particle has been given or weight has been given or volume has been given. If particle has been given, weight given, if weight has been given, so write down that weight divided by atomic weight. If particle has been given, the mole is equal to particles given number and divided by 6.023 into 10 to the power 23. And third thing, mole is equal to volume of a gas given, volume of a gas at STP, volume of a gas at STP divided by 22.4 liters. That's all. You have to remember these three formulas. So what I am trying to say, well, whatever I am trying to say, and before I say anything, join the Telegram channel of NEET. Here you are being given all the descriptions here, right? If you will be joining our channel, I'll suggest you to join our program, our courses, very valuable and very cheap. I'll not say cheap, very economical courses we have. You will find plenty of PDF materials. You'll find pre-classes. You will have a lot of announcements, and then we have a lot of discounts and prizes also that will be waiting for you, right? Join it immediately. We are calculating a web. Put mole here, right? We are putting mole here. You have weight can be given to you. You can be given volume. You can be given number of particles. Use any of the three formulas given first to reach to this platform, right? First you need to calculate number of mole, and number of mole you can calculate either by weight or by volume or by number of particles, as I suggested you, as I shown you the formula. If weight is given, divided by atomic weight. If particle is given, divided by 6.023 into 10 to the power 23. If volume is given, volume should be at STP. I explained you what is at STP. If volume is given, divided by 22.4. Right? Now, using this formula, whatever has been given to you in the question, first reach to mole. This, you have to reach to this junction. And from here, you should understand, once you have calculated mole, multiply it by atomic weight or molecular weight. Multiply mole, once we have calculated, multiply it by atomic weight or molecular weight, you will get weight of a substance. Multiply it by 6.023 into 10 to the power 23, you will get particle of that substance. Multiply it by 22.4 liter, you will get the volume of the substance. Look, I would like to explain you the logic of this, making this a relationship web. Suppose volume of a gas is given to you, right? Volume of a gas is given to you, and you are being asked, what will be the weight? Suppose I ask you a small question here, and very small question, you can relate it easily, and I'll let you know how this relationship web will be useful in solving this. Suppose, okay, Ilma, very good, thank you. Suppose I ask you that I have taken 10 liters of ammonia at STP, right? How many number of particles are there in it? How many number of particles are there? First, atom. Number 2, molecule. Question can be asked like this. This can be one of the very simple question in more. What you will do? What has been given? Look at it. 10 liters. What has been given? Volume. Start from here. Volume. Now first, what you have to do? You have to reach to mole. Convert volume into mole. Step 1. What will you do in step 1? Step 1, you will be converting volume into mole. How do we convert volume into mole? Take the volume, that is 10 liter, divided by how much? 22.4. Don't calculate it right now. This, we have got a result from this. Now from mole, where have you to go? You have to find out number of particles. And since it will be a compound, directly these particles will be molecule here. So if you multiply it by, as step 2, if you multiply it by 6.023 into 10 to the power 23, you will get number of molecules. Could you get it? 10 liters of ammonia, how many number of particles? 10 by 22.4 multiplied by 6.023 into 10 to the power 23. This is number of molecules. And let me know, if you are being asked how many number of atoms present in 10 liters of ammonia, then you will have to see ammonia here. Look, one molecule of NH3, or that is ammonia, contains how many atoms? 1 for N, 3 for hydrogen. There are 4 atoms. So if you are being asked this second question, first question, that is atom, so you will say what? 10 by 22.4 into 6.023 into 10 to the power 23 multiplied by 4. And if molecule is being asked, 10 by 22.4 multiplied by 6.023 into 10 to the power 23. Tell me, did you get it? Or I need to repeat or revise certain things? Any response? Okay. Well, again, relationship web for a compound. For element, you have found out. Again, the difference between, element and a compound will only be in atomic weight and molecular weight. That is one thing. Second difference will be, we will always be getting molecules, Avogadro number of molecules in a compound, but we will be getting Avogadro number of atoms in an element. So that is the difference. Once you know the relationship between molecules and atoms, which is very easy to see, for any compound, you can find it out how many number of atoms will be there. Sharon, what do you want me to repeat? Which area? Again, the previous formula or the question? I'll take up one more question. So that it will be further clarified to you. Now, what I basically am trying to tell you, like, look at this crisscross connection that I have told you. What have you to do? Weight, volume, particle, whatever has been given, take it to the stage of mole. Put it here. And from mole, you can take it to the particle stage, weight stage, and volume stage. This is what I am basically trying to say. Okay, I'll give you another example. Fine. Find you are given 12 into 10 to the power 23, 12 into 10 to the power 23 particles of helium. You have been given 12 into 10 to the power 23 particles of helium. What will be its volume at STP? Try another question. You are given 12 into 10 to the power 23 particles of helium. What will be its volume at STP? Take Avogadro number as 6 into 10 to the power 23. At times it is being done. Right? Okay. What have you been given? That is, you need to take it. You need to draw it always. You have been given number of particles. You are here. Number of particles. You have first to reach at this stage of mole. Now, can anybody tell me how many number of moles will be there in 12 into 10 to the power 23 particles? What has particle to be divided with? 6 into 10 to the power 23. So first thing we did, we divided 12 into 10 to the power 23 divided by 6 into 10 to the power 23. Instead of 6.022, we are taking 6 into 10 to the power 23 to simplify the things. So you got what? 2. 10 to the power 23, 10 to the power 23, it will be cancelled out. 6 into 2, it is 2. How many number of moles you got? 2 moles. So from this stage, you have reached to this stage. Now you are being asked, what will be its volume at STP? From mole, you have to travel to volume. Then you will have to understand 1 mole is always equal to 22.4 liter at STP. 1 mole is equal to 22.4 liter at STP. Now you have to calculate 2 mole is equal to how many liters? Because you have reached to 2 mole here. 2 into 22.4, it is as simple as this. Would you get this? Okay. Well, I hope the things must have started getting clear. Let us try another question so that you understand about it very much clearly. Suppose, what will be the volume of 4.4 gram of carbon dioxide? What will be the volume of 4.4 gram of CO2 at STP? Also find number 1, number of particles, number of molecules, that is one, and number two, number of atoms, number of atoms in it, right? So first thing, what have you been given? You have been given carbon dioxide, fine. First thing, you calculate quickly what is the molecular weight. You need to understand it is a compound, so you need to calculate molecular weight. What will be the molecular weight of carbon dioxide? Can anybody say quickly? None of you tell me all those things quickly. You need to tell me quickly. Anybody can calculate. You will have to calculate it quickly. Give me some reasons to smile. Give me some reasons to smile. Please, gentlemen. CO2 molecular mass. Sharon, Ilma, Athar. Okay. Should I calculate it for you? Molecular weight of molecular mass of carbon dioxide. It's 22. No, dear. Carbon is 12 plus 16 into 2. It is 32. Calculate. It is 44. So 44 is the molecular mass. Somehow you mistook it. Half of 44 is 22. Probably you took it. Okay. I'm receiving. Oh my God. Molecular mass of carbon dioxide, you're writing 32. You're writing 22. It is 44. Carbon dioxide, I'm asking. Molecular weight, I am asking. Molecular weight. Look, for carbon, atomic number is 6. Atomic weight is 12. For oxygen, atomic number is 8. Atomic weight is 16. Don't get confused by atomic number and atomic weight. Atomic weight is different, atomic number is different. Atomic number, number of atoms and number of protons present in an atom. 44, yes, 44 is correct, right? So you have been given, the second thing that you have been given, 4.4 gram of CO2. Now 4.4 grams CO2. From here, come to mole. Okay, no issues, Ilma. 4.4 grams CO2. Calculate number of mole. What will you do? Divide the weight given, that this is 4.4, divided by 44. How much you will get? You will get 0.1 mole. Fine. Now, what is the connection of mole and molecule? You know it better. The connection of 6.023 into 10 to the power 23. So you have 0.1 mole. That means 0.1 into 6.023 into 10 to the power 23 molecules. What does it mean? You can write it 6.023 into 10 to the power 22 molecules. Right? So you have got number of molecules in 4.4 gram of CO2. Now the third thing is you have to calculate number of atoms. Number of atoms. We need to emphasize, we need to clarify this, that one molecule of CO2 contains 3 atoms, 1 carbon atom and 2 oxygen atom, right? So 6.023 into 10 to the power 23 molecule will contain 3 into 6.023 into 10 to the power 22 atoms. Look, before moving ahead, I will advise you a couple of things. First, name of element, their atomic number and atomic weight. You should remember it clearly. That is the first thing. At least up to atomic number 20. Good, good, Sharon. Very good. Good. No, look here. 4.4 grams CO2 we have taken. 4.4 grams CO2 have been taken. So you have what? 0.1 mole. 0.1 mole. Now, if you have to calculate volume, Ocha, we have to calculate volume. Fine. So 1 mole is equal to 22.4 liter. Very good. I missed that. I calculated number of molecules and all those things and skipped. 22.4 liter. So 0.1 mole is equal to multiply 22.4 by 0.1. This is 2.24 liter. You have given me very correct answer, 2.24 liter. That is very good. But if you are calculating this, look here, 6.023 into 10 to the power 23 is being multiplied by 0.1. And if it is being multiplied by 0.1, then the power will be reduced. 0.1 means 10 to the power minus 1. So it will be added. So it is 10 to the power 22. Here I have written 6.023 only. So we have got 6.023 into 10 to the power 22 molecules because we had to calculate number of molecules in 0.1 mole, not in 1 mole. Are you getting my point? So it will be 6.023 into 10 to the power 22 molecules, not 23. Okay? See it once again. I'm just coming to my advice to you. Name of element at least up to 20, atomic number 20. I think it won't serve you the purpose. Atomic number 30, up to atomic number 30. You should remember and you should get it by heart. No excuses. Second, finding molecular weight. Finding molecular weight of as many compounds as you see. As many compounds as you see, as you come across. Okay? This is your teacher is advising. Okay? Try to abide by your talented teacher. Name of the element. Its atomic number, atomic weight. Finding molecular weight of as many compounds as you can. How many compounds do you come across? HNO3, H2SO4, CO2, NH3, H3PO4, CaCO3. There are plenty of compounds that you will coming across. So try to calculate molecular weight of these compounds. Thirdly, the relationship web that I have suggested you. I have suggested you how 1 mole is connected. You should try to assimilate them once again. If you have been given a weight or you have been given a volume or you have been given number of particles, first take it to number of moles. Without taking it to number of moles, do not move ahead. And once you have taken it to mole, convert mole into whatever things that is being told. Weight, volume or number of particles. Can you do this? So if you will be understanding these 2-3 things, I think your job will be over. And there is a last thing that I am adding to the mole concept. Right? Suppose I tell you or ask you 1 mole nitrogen, or if I say 1 mole oxygen, what is the weight? What is the weight? 1 mole nitrogen or 1 mole oxygen, what will be the weight? Those of you who will be considering nitrogen as N, you will say the atomic weight will be 14. And those of you who will be understanding nitrogen by N2, they will say it will be 28. Those of you who will be understanding oxygen by O, you will be saying it is 16. And those you will be understanding O2, you will say 32. But I have said one thing only. 1 mole oxygen. So the question is 1 mole oxygen means O or O2. There is an inherent drawback. And we tried to remove that drawback by giving mole a new nomenclature. And what is that? The another two name of mole is, first is gram dash atom, and the another name is, we call this as gram dash molecule. Now, saying 1 mole oxygen is not enough. You will have to say, suppose I say 1 gram atom oxygen, you will always understand this is indicating about an element and this is indicating about a compound. That means 1 gram atom oxygen is indicating O. And if I am saying 1 gram molecule oxygen, this is O2. Got the point? This can happen with H, H2, N, N2, O, O2. What else? F, F2, Cl, Cl2. There can be some more. So another name for mole has been given, gram atom or gram molecule. I hope you must have understood the concept of mole thoroughly well, and I think that is all what I have to say. More of whatever information that you need to have, I will give you through another channel that in which all of you are associated, and I hope you must have enjoyed this session. We have something more to say, and I would like to not cut short. This is the free classes that we are having regularly. So you should subscribe to us as soon as possible. Do it. It is for your advantage only. Coming to another part of it, I just wanted to solve more number of questions, but time is running short. I should tell you very briefly about our courses. Our courses that we have for you, it contains more than 90 plus classes. We have convenient educational platform, and we have syllabus coming from. Thank you, Sharon. Thank you very much. We have convenient educational platform. We have syllabus from well. No, you have to remember the entire compound in one step. Syllabus, we will explain you. You will be having syllabus from NEET experts. You will have flipped classroom methods. You will have doubt solving practices. And our classes will look like this, right? When you will be joining us, you will be getting plenty of theory as far as a particular chapter is concerned, as we are discussing right now. You will be getting plenty of study materials in the form of lectures, in the form of written material also. We conduct webinar as we are conducting right now. We can conduct webinar on each and every topic and topic of your choice also. And we give you plenty of homework also. And you will have to solve all those homework so that you can do pretty well. More you do the homework, more the things will be clear to you. And then homeworks will be checked too also. We have different plans that we generally prescribe you. We have light program, we have smart program, we have proficient program. The features of light program are these 4, as you can read it out. And the features of smart program are these 3, 4, 5, 6, 7 features: interactive live classes, structured courses and PDF, live tests, physical notes, one-to-one mentorship, live doubt solving classes, and mock tests regularly. So I'll suggest you to go for a smart program. It's very economical, and you can choose to use my promo code. That is, I'm writing it very specifically. This is NEETCHEM30. This is my promo code, and you should try to avail all the facilities which are there in Altedemy platform, right? Definitely, Elma, you will get all those facilities. You will getting all those facilities. Okay. See you soon. Thank you very much for staying with us. It was all very great pleasure being with you, and I hope you must have enjoyed and you have learned also a lot of things. Okay. Thank you very much.